In this video, we'll briefly discuss how inductances combine in series or in parallel. So let's get started by recognizing, okay, we have two inductors here in series. We want to combine them, like the circuit on the right, into one inductor. And what we need is to have the same source voltage Vs in both cases, and we have to have the same Is in both cases for these two circuits to be equivalent. So let's just write some things out given that. So for KVL, we can see that Vs equals V1 plus V2. Also, V1 and V2 are related to the source current Is because it's the same source current that flows through each inductor. So we can use the current voltage relationship to get V1 and V2. And then finally, we can simplify. Now, on the right equation, we know that V and I are related like this. And so it becomes easy to see, right, that if we're equating these, we can write following. And so we can divide both sides by this, and we have this relationship. We can also generalize this. So we'll conclude that inductors in series combine like resistors in series. We can then say similar things about inductance in parallel. So let's see how that works. Here we'll start with Kirchhoff's current law. And for the right circuit, we have this relationship. And we'll use the KCL from the left. More explicitly, we'll just write it here. And so that's what we've used here. Finally, we'll use the current voltage relationship for I1 and I2. So since it's the same voltage across the two inductors L1 and L2, we have this. And then we can write the derivatives as follows. Next, we're going to plug these in up here. And then we factor out the Vs. Now we can use this and we can divide both sides of the equation by Vs. So we have, and that leads us to the following. So that's our equation for equivalent parallel inductance. We'll just note that inductances in parallel combine like resistances in parallel. Okay, so that's a brief circuit theory video on combinations of inductance. Please like the video, subscribe to the channel, leave a comment below. I wish you the best as you study for your classes or you prepare for the FE exam.